Welcome to machinelearninginterview.com. Today we are going to answer what is the KNN algorithm, what are the advantages and disadvantages of using the KNN algorithm. Let's see. Let's quickly recapitulate what the KNN algorithm is. So why do we need nearest neighbor search? KNN stands for K nearest neighbors. So let's take a quick example of movie recommendation. Suppose we have a bunch of movies and we want to find the 5 closest movies to the movie matrix. So what we see here is that if we are able to represent each movie as a data point here, then what we need to do is really come up with those data points, the 5 data points that are closest to the data point matrix. And then you would actually show the user these 5 points. And there are many other applications, of course. It is very commonly used in different kinds of recommender systems or even tasks such as information retrieval or an application like product search or question answering from FAQs maybe. So it could be used in many different applications, and nearest search is an important problem. What is one of the biggest challenges here? As the size of your data set grows, it is harder and harder to search, because if you do a naive search here, you have, let's say, capital N data points, and you have K, which is the number of items you're trying to retrieve, and suppose, let's say, D is the dimensionality of your data. Then the complexity of this search is N into D, because each comparison, so you are actually going to each, for matrix, you are going to each other data point and seeing how far it is. So usually the computing distance itself will take order D if it's D-dimensional data, and then you have a total of N data points, and you want to do this K times in the most naive case. You might definitely do it more efficiently here. So this is like very huge, and there are many algorithms to actually do this more efficiently. So one of the ways, for instance, is to partition the data to organize these points better, so that you do not need to go and look at the distance to all the points every single time, but you have a notion of nearness. For example, using a hierarchical data structure such as a KD tree. So while we won't go into the details of KD tree, you will see that if you go to the scikit-learn library, nearest neighbors will have a bunch of different algorithms. So you can use a ball tree, KD tree, and so on. So these are different ways of organizing data so that your algorithm is more efficient. Okay, so how does nearest neighbor algorithm work in a classification example? So KNN can be used for classification. So if we quickly want to see this, suppose you have a bunch of positive examples and a bunch of negative examples. So in a KNN setting, given a new point here, you would actually take the K closest points. So let's say K equals 3. So you will take the 3 closest points here, and since it has a majority of negatives, you will actually say it's a negative. Similarly, if I'm given a point here, I will once again take the 3 closest points and say this is a negative. Right? So this is KNN for classification. Pretty simple again. So we have seen how the nearest neighbor search can be used in an unsupervised setting to retrieve similar objects. It can also be used in a supervised setting for classification and regression. Let's very quickly see how. So suppose you have a bunch of positive examples and a bunch of negative examples. The KNN algorithm can be used for classification by as follows. Given a new point, you retrieve the K nearest points using the nearest neighbor search, and then you aggregate those labels. So if you have more negatives here, you would say the outcome is negative. If you had more positives here, you would say the outcome is positive. Right? And once again, you have the K nearest neighbors classifier in scikit-learn, and you have the same challenges of dealing with large data sets. So you once again can use one of these algorithms here to make it faster. And also another point to note is that you have a choice of different distance metrics usually when you use K nearest neighbors. So Euclidean distance is one option, but you can use any distance metric pretty much depending upon one that makes sense for your application. How can you use the KNN algorithm for regression? So very quickly, suppose you had a bunch of points in the supervised setting, you also have the target values which are continuous for these points. Then I would take, given a new point here, I would take the k nearest neighbors using the KNN search and then aggregate their value by taking like a mean and then giving out the final target variable for prediction. Okay. So once again, you can actually use KNN regression from scikit-learn here, and you have similar parameters again. What are the advantages and disadvantages of using the k nearest neighbor algorithm? So the first advantage is that the algorithm is simple and intuitive to use. It's a very simple algorithm. The second is, in a supervised setting especially, there is no training time. What we mean by this is, if we take an algorithm like, let's say, an SVM or a logistic regression, you would actually need to train and come up with a model and then do the prediction. So there's no training in KNN. Everything is really, all the complexity really lies in the prediction. So there's no training. It can learn non-linear decision functions. So for instance, if I have like a non-linear decision boundary like this, KNN can handle this pretty comfortably without having to do any extra effort. So if I have a point here, it would actually take the average of labels around this region. If I have a point here, labels around this region, and so on. So it can actually do this kind of a decision boundary, and the value of k determines how smooth this boundary is, or how much the boundary is actually capturing the complexities in the training data, in which case it might overfit. So if you reduce the value of k, you might get like a wavy boundary like this, but if you increase the value of k, you'll usually get a smoother boundary, and there's a trade-off there, right? So we can learn nonlinear functions. It evolves with new data. Since there is no training, and if you add some data points to your data set, you add some new data, then during the prediction, it automatically is taken into account. There's nothing you need to do really. So that's definitely an advantage. There's a single hyperparameter. That's just the value of k. Of course, there are other hyperparameters like the distance metric you use and the algorithm, like the k ball or kd tree and so on. But the ball tree or kd tree and so on. But it does not have a lot of hyperparameters, unlike some other algorithms. If you take like a random forest or a decision tree, it has many more hyperparameters that you can tune typically. Choice of distance metrics. So if you take a problem which requires a different distance metric, you can actually easily modify it. So for example, if you have a set of binary vectors, then you can use a different distance metric which is not Euclidean. What are the disadvantages of the k nearest neighbor algorithm? So the first is challenges with size of the data set. So if we have large data sets, the prediction time increases. Why is this important? So if we have an application where we are using KNN in the back end, the user makes a request, we immediately want to apply the prediction logic and come up with a predicted response. You can't make the user wait for like few seconds. So it's important for the prediction SLA to be tight. Now in KNN, if you want to make it better by giving it more data, it actually increases the prediction time, which is not desirable. So there are ways to address this particular challenge, which we're not talking about right now. Another challenge is when we have high dimensional data, if the number of features is high, then computing the distance metric between one point and the other itself takes time. So again, there is high prediction complexity. So if you recall, we actually looked at the complexity of the naive way of doing it is, if we have n data points and m dimensions, it's actually the product of m and n. So if m increases or n increases, we have a high prediction complexity. The third is that it gives equal importance to features. So what we mean by this is that if you take a distance metric like Euclidean distance, most distance metrics that we choose that are customarily available give equal importance to features, which means even if all the data points are closely clustered, are very close to each other in many of the features, but there is one feature in which they differ a lot. um, Depending on the application, you might really want to consider them, near and not far. So sometimes it's important to actually come up with custom metrics to overcome this particular challenge. Sensitivity to outliers. So suppose I take this example here. I have some positive examples and some negative examples, and there are some like couple of outliers here which in between the positive cluster which are negative. So if I take a point here and I take the three nearest neighbors, I would end up classifying the point negative. So this is not desirable. If we take something like an SVM, or a logistic regression, it might slightly shift the decision boundary that it's learning because of the outliers, but then it will still learn some kind of a decision boundary like this, and we will not have this problem of actually misclassifying the point, right? So this is one challenge with KNN algorithm. Another is, it's sometimes bad with imbalanced data sets. So if we had more positive than negative examples, especially near the boundary, we might actually end up facing a problem. So the challenge though is local to the boundary. If we go to the interior of a particular class, we typically might not have this challenge. So these are some of the advantages and disadvantages of KNN algorithm. Thank you.